we present an automatic system to generate mechanical figures that mimic human motions. The input to our system is a periodic motion sequence of an articulated 3D human figure. First, in the motion approximation stage, we decompose the input motion into the motions of limbs that can be approximated by planar oscillations of individual bones. Then, in the layout stage, we generate a physically valid layout of the mechanical components that realises a simplified target motion and respects the proportions of the bones in the input figure. The resulting automaton can easily be fabricated. The planar mechanical parts, such as gears and linkages, are laser cut. We use off-the-shelf pieces for the remaining pulleys, shafts and pins. Our designs can be driven by a single input motor as shown here. To move each bone of the mechanical figure, we introduce an oscillation model that uses gears, a pulley and a 4-bar linkage. The 4-bar linkage converts unidirectional rotation to oscillation. The output crank of the linkage drives the link attached to it. The pulleys propagate the input rotation to the subsequent links. Here we show some examples of generated automata from various human motions obtained from the CMU motion capture database. Here is an exercising sequence. Here is a jumping jack sequence. And a dancing sequence. Finally, here is a ballerina sequence. While the input motion to our system can be selected from motion capture databases, commercial motion sensing input devices such as the Microsoft Kinect enable the users to directly perform the desired motion as shown in this kendo sequence. Here we show physical prototypes for some of our examples. In the walking example, the motion of the moving limbs are projected to parallel planes. The torso is orientated parallel to this motion plane and is used as the main support structure of the mechanical figure. Pulleys are used to propagate the input crank motion to the moving limbs. The whole mechanism is driven by a single input motor. In the dancing example, the motion of the arms and legs are projected to orthogonal planes. Bevel gears are used to convert the rotation of the input crank to the appropriate motion plane. The whole mechanism is driven by a single input motor. Thank you.